In this video, we're going to look at example 5, where we divide rational expressions. So we're asked, what is the quotient of x cubed plus 3x squared plus 3x plus 1 over 1 minus x squared and x squared plus 5x plus 4 over x squared plus 3x minus 4. Now, this is a pretty annoying problem looking at it. I dislike when it's the difference of two squares and the variable term is second. It tells me I'm probably going to factor a -1 at some point. The other thing I want to kind of keep in mind is that this here is an annoying problem to factor. We won't recognize it right away, so there is a shortcut we kind of need to be aware. I have it written out on the side, but we'll get to that in a second. So this problem right from the start annoys me. So we're going to have x cubed plus 3x squared plus 3x plus 1. However, the nice thing about this is using this as an example, the problem shouldn't be any harder than what you're going to see here or more involved. This pretty much covers everything. So we have x squared plus 5x plus 4 over x squared plus 3x minus 4. Very similar to multiplication. First step is always going to be factor everything as much as I possibly can, and then always keep the domain type material in mind as we go along. So I've already written out the work or the note on the side up here in the top. So of how I would factor this numerator. It's the sum of cube rule. Basically, it follows the pattern. So we have x plus 1 cubed. However, I'm going to write that as x plus 1 times x plus 1 times x plus 1. So just want to keep that in mind. And then my denominator, 1 minus x squared, that's going to be 1 plus x times 1 minus x. Stick with division for now. And now I need to use my factor sum method. I need factors of 4 that add up to 5. That's pretty easy. X plus 1, x plus 4. Not a lot of stress there, which is nice. And then x squared plus 3x minus 4. Same thing, factor sum method. So we know we're going to have x times, or x plus minus. So we need the larger number to be positive. So this is going to be x plus 4 and x minus 1. All right, so I've factored this. However, I really don't like this. So I'm going to change that. I'm going to write this whole thing out again. So let's make that x plus 1, x plus 1, x plus 1 over, and then let me write the other ones out, and then I'll go cover that new piece. All right, so this 1 plus x is going to stay the same, but I'm going to rewrite it as x plus 1. And then this 1 minus x over here. So if I have 1 minus x, I'm going to factor out -1, so that's going to become -1 plus x. And then I'm going to rewrite that as -1 times x minus 1. All right, so this piece here is what I'm going to do with this. So this is going to be that -1 and then x minus 1. It's always easier to write that in that form. You'll see as we go, things will cancel out kind of nicely. Okay, so next part of this, we need to look at domain. Domain is important at multiple steps because things are going to change. So the domain is going to be all real numbers. Remember, always look at your domain once you're done factoring. So all real numbers except. All right, so what creates the denominator of 0? So we're going to look at each one of these pieces. There's nothing here I have to worry about. Here, this piece here, we can't have -1. Here, we can't have a +1. Here, there's x plus 4. We cannot have -4. And here, we can't have +1, but we already covered that, so we're good there. All right, so right now, my domain looks like I can't have -1, +1, or -4. Now that we're dividing, we want to turn this into a multiplication problem. So that's not what I wanted to do. We're going to rewrite our first fraction exactly as it is. We're not going to change anything about it. However, our second fraction, instead of dividing, we are going to multiply by the reciprocal. So my numerator and my denominator are going to be switched or flipped. Okay, so what I did here, let's not use the same color, is I took this numerator, or sorry, the denominator made it the numerator, and my numerator became my denominator. Okay, the reason I did that is because I'm now multiplying instead of dividing. Okay, so that was being changed. Take note of that. All right, now we can start combining everything. So let's write this as x plus 1 times x plus 1. My numerators are going to get combined, so I'm going to bring that x plus 4 and x minus 1 over. Remember, these problems would be an absolute nightmare if we weren't able to cancel anything out. All right, so now my denominators will get combined. I'd be very unhappy with this problem if I needed to multiply all these terms out. Luckily for us, we don't. So let's start canceling things out. I have an x plus 1, those can be dropped out. I have another x plus 1 and another x plus 1 that can be dropped out. I see x plus 4 can be canceled out, x minus 1 can be canceled out. So what I'm left with in the numerator, I have x plus 1. In the denominator, all I have left is a negative 1. So we can definitely rewrite this as negative 1 or negative x plus 1, right? Dividing would bring that kind of negative on the outside. Now, what's really important is we talked about domain, right? Domain is when the denominator, we can't have any part of the denominator be 0 when we're multiplying. But be very careful, because at this step right here, we had something, the x plus 1 that's highlighted in orange was in the numerator, but now it's dropped to the denominator. So we need to look again at here. All right, we have new terms in our denominator. They weren't there before, so we need to check again and make sure our domain is okay. Here, this cannot be negative 1, and this cannot be negative 4. We already have those ones listed, so we were lucky. There's no extra work here. We don't have to add anything to our domain and range, but there is the chance that something, when being switched, there's going to be a number added to your domain, or an exception added to your domain. So be very careful with that. What I'd like to tell students or anyone doing this is that you should be looking at the domain every step along the way. All right, so we're always looking at the denominators and making sure that everything is okay. As a quick example, let's say you had like x plus 1 and x plus 2 divided by x plus 3 and x plus 4. So right now, x cannot equal negative 4. However, if I was to switch this, right, and that numerator and denominator get flipped, well, now x can also not equal negative 3. So when you switch from division to multiplication, you do want to be very careful with your domain. Exceptions, new numbers can definitely pop up, and we don't want to make simple mistakes or lose credit on problems, get things wrong with the domain just because we were a little bit careless with that. So here, our final answer would be negative x plus 1, and we would say that x cannot be equal to negative 1, positive 1, or negative 4. You can put those in numerical order. It's not a big deal to me, but we're good here. All right, and that's it. The division ones do wind up being a little bit of work. You will see, you won't have ones like this one where we factor this here. You're not going to see that come up. So don't stress about that. Just be aware of the process, know how to do these type of things, how to factor, and how to cancel out and switch your fractions.